that on the exam. It's like, I am taking this exam on iLearn. True.
Yes, I am.
Okay, so let me open up the quiz.
It's funny because I felt like I knew more than I thought I did.
Yeah.
And then there was a couple of things that kind of was like, wait, what? But for the most part, it was manageable. I'm a little worried about taking it without a book.
Well, just page notes and
yeah, that page notes is neat.
Yeah, but now we've had another exam. Shouldn't we have the other page to use?
Well,
right?
What you do is you put it in your computer and then shrink it.
I can barely read it as it is.
I actually
That's
one
clever,
time
though,
I had
Jesse.
this huge trig final a while back in one of my pre-calc classes, and they said you can use a double-sided note card, so front and back. So what I did is I went to Photoshop, created this master list of formulas and conversions and all this awesome stuff, and then I shrunk it to the perfect size of a note card, and then I gave it to a bunch of my classmates that all studied together. I was like, "There you go, man. There you go."
That's awesome.
And it was useful.
You guys did well then. Good.
Nice.
You're good.
Always technology. Any way I can help myself.
Yeah, I suppose I could write a second page of notes and then copy them to one page, but there's so little. My writing is already smallish.
Smallish.
Well, these are my notes. So, could be smallish. I haven't made my notes for the test for this test yet. So
my main thing is just the formulas is what I like, how they're laid out is my main thing that I not necessarily struggle with, but that it helps me the most to remember. Because just for me, I was originally a math. Well, long story, but I have been a math major, and so formulas and things are my forte. And so if I can see a formula, it helps me for some reason. I can remember a lot of the stuff behind it, like what each variable is, and so that's why formulas are the main thing that I need on notes.
That's true. That's good. So did you say you got number 2?
I always get confused on this question because I feel like because I always thought the book said there was 3 different ways you could explain what that means, but I always thought the best one would be we're 90% confident that the true mean heart rate is between 45 and 105, but I don't know for certain if that's right or not.
So question 2 is, let's see, we're 90% confident that it's B. I remember writing that down.
Yeah, we're 90% confident that the true mean heart rate is between 45 and 105.
Yeah.
So on to 3.
Oh, this is the one I just started looking at. And that's where I couldn't remember.
Yeah, I thought this one might be B because there was a couple requirements. Well, no, because they have the QQ plots to see if it's normal, and I can't remember what the other requirement was.
The variance.
All the variances are equal, so they don't know if the variances are equal or not. But that doesn't seem to be something that they mention.
Well,
so maybe it's C.
So how many are in here? Hold on, let's see. What does it say?
It's 20-something. 30-something.
Oh, you know what? There's only 2. There isn't a variance. We don't have to worry about a variance because there's only two sets of, there's two groups. Does that make sense? If we're using an ANOVA, we would
Yeah,
need a
'cause
variance.
yeah, you guys are thinking of something else. Yeah.
Oh yeah, you're right.
So
So yeah,
I
so
see.
yeah, I think it'd be C because the data are shown to be normal. Good catch.
I think I actually had to
And
look at it.
And then for the 4 types of confidence intervals, they're testing to see whether the stimulus time differ between males and females. And they don't tell us what the sigma is. So, because I don't think it's talking about independent or dependent samples because.
Mm-mm.
So, do you think it would be the confidence interval for you when the sigma is unknown?
That's what I put. Hope it's right.
Do you think that sounds right, Jesse?
Different from the other females. Well, we don't know sigma, and then the mu is what we would calculate from the data that we have. So yeah, I'd say B.
Well, cool.
Okay, so which of the following?
Could it be? Differed from that of females.
You know, you cut out really bad. Did it for you too, Tab?
Yeah, I was gonna say I kind of cut out a little bit. I didn't quite hear what you said.
Oh, I was thinking maybe it could be C for number 4.
Mm-hmm.
Simply because in the information for the problem, they just said want to determine whether the reaction time of males differed from that of females. So you're going to have to be using 2 different, which means a difference, right?
No, because they're not dependent on each other, right?
Well, there's an independent one.
They're 20 versus 15. Am I wrong thinking that?
Well, I was just thinking because like a null hypothesis would be like they're equal, and then the alternative hypothesis would be just that they're not equal. Mm-hmm. So for that, it's just like I'm not sure. I can't remember what. Okay, because when it's an independent,
it means, huh? You're right.
With the because I remember like for the 2 means independent samples it talked about, it had to be a simple random sample, and that the distribution from each group had to be normal. Mm-hmm. But I feel like I'm not sure if it's talking about like you're comparing the mean of each one. You're just seeing if one of them is different than the other. You're not testing like you're not testing the change between them. You're just testing to see if they're equal or not.
That's true. Okay.
I don't know. I guess it could go either way.
No, I like your reasoning. Yeah.
I guess if it's wrong, we know we can switch it on the second attempt.
True.
Okay. Sorry to complicate things, but I was just like,
oh no, it's fine. I appreciate because it's good to think it through. So when we want a smaller margin of error, on the next question, number 5.
Mm-hmm.
Yeah, you'd want a bigger sample.
Good. So the last one.
Yeah. I actually remember, because I think I got that wrong on one of the homework or quiz questions where it's like, what would happen to the margin of error if we increase the n, or the sample size, and it shrinks? Because basically we're that much more confident. So you only need, if you're thinking of the applet, you only need a narrower section to be like, yeah, I'm confident.
Yeah, because it makes sense.
Yeah, because instead of casting a wider net, you can say no, because I have this much data, I'm right here. So
yeah. Yeah. So number 6. I remember this one is like, I figured this out when I was studying. It's like, remember how before we were talking about how the margin of error, we do like the
like the 1.96
upper bound minus lower bound divided by 2, and then there's like the other way to do it when you don't have all the data, where it's the little statistic, the 1.96 times.
And so I think that's what we have to do here, huh?
Yeah.
Yeah, because we've got the standard deviation, we've got the mean, and we know we want the 1.96 in there.
Yeah, so I'm just trying to. So it's the 1.96 times the standard deviation divided by the square root of the sample size.
Yeah.
So it tells us the sample mean, but we don't even need to use that in the problem, do we?
I wonder if I'm getting the opposite.
Sample mean.
Because what I did was
Well, no, wait. Don't we need one more piece of data, or am I missing something?
Well, because like we have the margin of, we have the 1.96, and then the standard deviation is 2, and then the sample size, it says she randomly selects 4 drive shafts made at the factory.
Oh, so I'm looking at the wrong formula here. Yep.
You know what I did, guys? You guys can tell me what you think. I just put in 95% error, and it's a margin of error of the standard deviation, which is 1.96. So you go either way, right?
No, I think we can use the Excel, but instead of, because remember there's that section where it's like, instead of putting in the data, you can put in the key indicators or whatever.
Okay. So what did you get for 6?
Well, like when I did 1.96 times 2 over radical 4, it's just 1.96, because radical 4 is 2.
Yeah.
2 divided by 2 is 1 times 1.96, just 1.96.
Okay.
So I don't know if that's totally off, but that's the only way I know how to do it. And then for the lower bound, we have to use the actual formula. So I guess that's when we use the mean, because we have to do the mean minus that, and then the mean plus that.
I may have done this completely different than you. Hold on. What was our... I think I used the applet for this one.
I don't think you need to use the applet for the margin of error.
Well, what I got was, for 7, tell me if you think this is right, 998.040.
That's what I got for it, but I just used the formula.
And then for 8, I got 1001.96.
Yeah, that's what I got too. I just used the formula for it. So maybe you can use the applet, but yeah, I didn't need to. I just used the formula. But whatever works. Is that what you got as well, Jesse? Does that sound right to you?
Sorry, I was just going through using the because I had started computing things using finding the z-score. I was like, wait a minute, we need something else. And nope. Okay, so then confidence, la da da. So the margin of error is just 1.96, right?
That's what I think.
Okay, yeah. Lower bound, upper bound.
You know, Todd, the reason I think I could wing that is because the standard deviation was 2. If it had been any other number, I would have had to use the formula. But because it was a simple 2, I could just figure it out.
Yeah. Well, you're always really good at finding ways to solve those problems that I never think of. So
back way, which is probably very, very wrong. I'm not doing myself any favors.
If it gets you the right answer,
okay, so then for the lower bound, we would just take the 1,000 minus
1.96.
Yeah, 1.96. So we get 998.04, and then upper bound would be 1,001.96, right?
Yeah.
I'm still having to train myself because, like I was saying the other night, like for some reason, I had been thinking of the margin of error in percentage terms, and I have to remember it's in the units of whatever the data is. So I don't like large numbers for the upper and lower bounds, and I was like, wait a minute. All right.
So this is where we have to use that formula with the n equals the z times the theta over m.
Oh, yeah.
Squared.
Yeah, squared. Can't forget the square.
That would definitely give you a different
So I did do a formula. Are you proud of me?
Yeah.
Okay.
So
Z
1.96
sigma over m squared
times 2. And then divide that by m. That's the mean, right? The 1,000.
Are you doing 9? Todd, are you doing number 9?
Yeah.
Standard deviation.
Maybe I did it incorrectly. I did 1.96 times 0.01.
Oh, wait, yeah. And then
over the quantity of 0.0001, and then that whole quantity squared. Is that what you did?
I think that's what you should do, yeah.
Okay.
What was the answer you got for that? Just so I'm going to try and do that now, just to see if I can check it.
38,416. And who knows?
I won't not. I just want to open a new window.
Hold on.
I'm going to try and piece it together in Excel so I'm not like making sure I'm doing weird calculator errors.
Yeah, some of these you have to do in Excel.
Yeah, that's what I got, because 38,416.
Awesome. That makes me happy.
38,416.
Woohoo!
A lot of times to weigh that. Holy cow. I guess when you're dealing with such a small weight of measurement, I'm like, whew.
It's a big sample size.
Yeah.
So number 10, the mean area is blah, blah, blah. Tenant group thinks blah, blah, blah.
More of that.
Okay, so the null obviously would be that they're equal, and they think they're smaller. So it would be D. Yeah, I concur. And
did you watch Catch Me If You Can recently?
Not recently, no. I haven't. Oh gosh, I haven't seen that movie in ages.
I just remember the scene in the doctor's office where it's like, "Do you concur?"
That's funny. I totally
just
forgot
trying not to throw up.
Yeah. I remember watching that in high school.
I've never seen that movie.
It's a really good one.
Yeah.
And I mean, obviously it's fancified, but like it's like a lot of the security on checks came from him.
Oh.
Yeah, because it's actually based on a true story.
Yeah, Frank Abernathy. Yeah, and then like a lot of bank security stuff came from him, in addition from checks, and yeah, it's really interesting. Anyway, moving on.
Hey, we're learning.
I think question 11, we reject the null when the p-value is less than A, right?
Agreed.
A group of statistics students want to take their test before 11 p.m. tomorrow, but they also want to determine.
Not allowed.
They collect GPA.
What? No. Sorry, Judah. Just play the Switch, please. Oh, so from each building. Okay. So shape with no outliers.
The data for each apartment building are bell-shaped with no outliers. Sample variances are nearly equal. Yeah, I think they should be able to, right?
Yeah.
Yeah.
Yeah, I think C, because I'm pretty comfortable with that.
Yeah.
Medical researcher working on new treatment for a certain type of cancer. The null is its average survival time is the same. Early trials who tries a new treatment.
2 years.
Okay, so she rejects the null, and it turns out that the null is true, right? Because it's in the future study, it's saying, yeah, I think that's a type 1 because it says that later the treatment doesn't change the time. So she rejected the null when it turns out the null is true because later they said, oh yeah, it doesn't change it, so it's equal. So it's a type 1 error.
Oh, hold on. But in the future study, it's determined that new treatment does not increase the mean survival time.
Because the null is that the times are the same. And that's what the future study found, is that there's no evidence to suggest that the times are different. Is basically what it looks to me like what it's saying.
And so that's where rejecting the null, even though it's true, that's the type 1, right?
Yeah, that's what I thought.
I cannot remember.
I think the way you explain it is like a type 1. Yeah, it was like one of them was like a false positive, the other was a false negative. Like type 1 is when you reject the null when the null is true, and then type 2 is when you don't reject the null when the null was false.
Yeah.
Like a false negative or false positive.
Actually, I really like the table that they have in the book.
Yeah, I like that as well. That really helped me understand it.
Yeah.
Yeah, I feel like I got a grasp of it just reviewing, whereas when we were doing it, I was clueless.
Yeah, I actually like. Yeah, it's helpful.
That's definitely one of those things that I would put on my sheet because, like, for some reason, I'm just like, when 1 is true, I reject. Wait,
good thing to put on the sheet. Yeah.
And then for 14, I think it's A, because like when you reduce the probability of committing a type 1, you increase the probability of committing a type 2. Just like
it's kind of like the inverse.
Yeah.
Yep.
So we increase probability of type 2. So A. Oh, that's good. 3. This
is one I just kind of finagled.
Greater level of 0.5 significance. You conclude. Is this? Do we need to do a little z-score stuff, or?
I think this is just asking us to interpret what it's saying. I know, because when they say that the mean is 1.5 and the standard deviation is 0.17, and they're saying that their sample mean is 1.53, that's not really that different than 1.5. It's within the standard deviation. It's within one standard deviation of it. It's like barely off of it.
I guess that's true.
So I'm thinking you would, just my initial guess would be that you would fail to reject it just because it's not really that different.
Yeah.
But I'm not entirely certain.
Because one standard deviation would end you up at 1.67, and yeah, that's pretty far within. Like, that's like not even 0.1%, you know?
Yeah.
Well,
just my guess. You would like to look at the mean number of hours worked for wages per week by male students and female students. You like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? I don't like these questions.
I don't either.
Yeah. I remember there was a whole section, and I want to go back to it. Kind of like the null hypothesis, like what to do with them.
Because
they gave a whole table, and it was on the homework. I remember too. It was like,
I remember that too. Yeah, because it was like the one mean sigma known is like the normal distribution with like the one sample z test. The one mean sigma unknown is like a t distribution, and then the two means paired is a t distribution, and the two means the independent or t distribution.
Where was that? I guess it was in the homework.
Yeah, I remember that was. I think that was last assignment's preparation assignment. It was one of the last couple preparation assignments. But for this one, you're just looking at. It says you want to test if the means are different.
Okay.
So I'm thinking that it's either.
Okay, so this is what the little table says in the answer from the answer key. It says hypothesis test for two means independent samples. Data are simple random sample. Distribution of sample means each group is normal. T distribution. This is independent samples.
See, I just kind of eliminated. I knew it wasn't an ANOVA. I knew it wasn't one sample. I knew they weren't paired because they weren't related to each other.
Right.
And I knew, again, it wasn't a one sample. So it just, by process of elimination, I came up with independent sample.
Yeah, and I think one of the things that gives it away is that it's saying that you're testing if the means are different. Because the other ones, you're just kind of testing if the data is different, but this one's specifically looking at the means of two groups. You know what I mean? Like before, it's just like, oh yeah, we're going to see if the wages are different between guys and girls. You know, it's like the nulls, like they're equal, and the alternative would be like, oh yeah, we think one's higher than the other. It's like they're just kind of comparing, but this one, like they're just seeing if the means of those independent data sets are different. So I think it's B.
Yeah.
And 17, I think, is a bit easier.
Mm-hmm.
So that's dependent sampling.
Yeah, because if you select a brother, you have to have their sister selected as well.
Yeah, so D. Is that what we're saying?
Yeah. And every big brother just rolled their eyes.
I'm the youngest, so that doesn't really work for me.
Okay, your big sisters rolled their eyes.
Okay, so soil scientists collected random soil samples from a field, measured the dissolved organic carbon level of each sample. Sounds exciting. Measurements are recorded. I think this one, would that be confidence interval for you when the sigma is unknown? Because it's not like a dependent or independent sample, because it's just kind of comparing one set, and we don't know what the population standard deviation is.
That was my guess.
So I'm pretty sure 18 is A.
Agreed.
And I'm just going to look at what I answered on when I went through because these are on the review. I remember I went through and did it. I want to look see what my answer was.
Okay, I'm gonna try and do this here real quick. So 95, so it'd be Oh wait, is this the one where we just do the upper bound minus lower bound divided by 2? Is that not what we're doing that on these?
Mm-hmm.
I think we could, like, if you were to open up that file and you can put it in Excel and it will do it for you.
So I was just thinking, I was like, I don't really want to do that. Which one was it? Dissolve organic carbon. I actually almost wish there was like a master, like not just like download, but like one Excel file that had all of the data, so I didn't have like 18 to scroll through.
There is one file.
Wait, what?
Yeah, I only just discovered it.
That has all the data in one file?
Huh? On that page where you're opening the page and all the data are listed, there's an option somewhere on there where you can download the whole file.
Oh, but that still has individual Excel files, though. And so I have all of them, but they're individual Excel files. I'm talking about like each like page and each sheet is like a data set. But that would be a lot of work.
So we don't have to open it? Yeah.
Okay. Okay. At 2.025. Margin of error.
That's what I got.
Yep. And then lower bound, I got 11.168, and upper bound 15.217.
Yep.
Woohoo!
Sweet. And this next question, they used Hummers. I didn't understand this one because, like, on the review, it was like, which of the following is a 95% confidence interval? And what was showing up for me on Excel wasn't any of the options that they were giving.
Oh no.
So I had no idea what was happening with that. So
I put in B for this one.
Holy cow. That is, oh my word.
I know, like, just like looking at that data file just gives me a headache.
Yeah, because it's got like 5 different ones.
Well, because it's got everything. It's got year, it's got make, it's got model, it's got mileage. I'm just like, wow.
It's like all this useless information. Like all we're comparing is the price in Los Angeles to the price in New York.
Mm-hmm.
Like we're not even
had 2 columns for us.
Yeah, so I'm pretty sure this one. we're looking for a confidence interval for the difference of means using independent samples, right? Because it doesn't
Yeah.
because the cars from one don't
Yeah.
determine where the cars are from the other.
Yeah, exactly.
But then, yeah, the confidence interval is
Okay, so let me put.
I'm gonna
the
do it
data in
again
here
and see
for a
if
second.
I'm gonna try it again and see if I get anything different. But
So for 22, did you guys choose C?
Okay. Freaking, where's the list? My gosh.
so for this one, we're not using a paired sample t-test. We're using the two sample t-test for means.
Yeah,
Is
two
that what
sample.
we're using?
And then let's see. LA was which one?
Oh, I think I found out what I did wrong. So I think before I accidentally put the data into the paired sample instead of the two sample.
They're different. They're two different amounts. One's like 109 in a sample set, and the other one's much, much less. I can't remember the number, 63 or something like that.
Okay. Oh, yeah, I got this weird confidence interval. Okay, right on. Love that.
Yeah, it seems like New York has a lot less than Los Angeles does.
Mm-hmm.
So for your comms drill, did you get negative 423 and then 5,417 point something?
Yep.
So my margin of
Okay.
error is 2,920.287.
2,920 point what?
287.
What is that
Oh
number?
wait, we're not doing the. Sorry, I thought we
Yeah,
were asking for the
it
margin.
doesn't even ask for it. It just the lower bound is the negative.
Like, where is that number?
I started jumping the gun because they usually ask for that. Oh,
They usually
Yeah.
do.
freaking A.
Okay, I won't panic.
So minus 423.238. 23.
Yeah, I'm really glad because like I know what I did wrong is like I accidentally put it in the paired samples and I got a totally different confidence interval. It was like stressing me out, and I realized I just got to put it in the right one because it makes a difference.
I started out doing the same thing. I actually think those spreadsheets help us answer the questions. So I'm glad we have access to those.
Yeah.
Bones. Oh, let's try. Jumping warehouse.
So for this one, I'm pretty sure it's a Nova.
Mm-hmm.
Right, because they're basically all independent, but you're looking at three groups here.
Yeah.
I think this is when we just plug in the numbers and record the data.
Yeah.
What was the file called? Exercised bone density. I don't know why my computer system is running a bit slow. It's frustrating.
I feel like half the problem, like half the battle, is just deciding which test it is. And then basically from there, you just find, like, it's pretty easy just once you figure out which tab in that spreadsheet to put it in.
And I mean, it definitely shows, like, because they ask such simple questions about each one. You're like, yeah, if you're doing the wrong test, you're gonna know, like, you're gonna not get anywhere close. Kind of like, you know, you had with that last problem, you know.
Yeah.
Oh. Okay, because they want the test statistic.
What'd you get?
7.978.
Yep.
Yay! Okay.
And the p-value is 0.002.
Awesome.
So that's less than our level of significance.
And by like a factor of 10 at least.
Yeah, so we are rejecting the null. So we're basically saying that there's sufficient evidence. So I'm pretty sure 28, would that be D, that there's, or I'm sorry, C, there's sufficient evidence to conclude that at least one of the groups is different from the mean bone density of one of the others.
Yeah, that at least one is beta ANOVA.
Oh, let's see. Where is that one? Precision. At least, okay, there we go.
Or would we say there's insufficient evidence to conclude that the mean bone density of all three groups is about the same? I feel like it could be either one.
No, I remember on the ANOVA ones, you basically only have enough to say that one where it's at least one is different, because on the ANOVA hypothesis test, you're saying all the means are equal. And the alternative, is at least one of the means differs. And
Okay.
so to say any of the other ones would require more hypothesis testing.
Okay.
Yeah, you were right with the first one. The sufficient evidence to conclude that bone density of at least one is different than at least one of the other groups.
So it's D then?
Yeah.
Okay. And this next one, I recognize this problem from this problem was on one of the homework quizzes.
Yeah, we did.
Oh, really?
Yeah. The direct flights. It's a dependent sample.
So a paired sample t-test.
Because you're looking at the ticket prices.
It was that girl, she went and found data from one airport and
so
90 days versus 14.
Yeah, I was like, so I just opened up the homework quiz and pulled my answers off of that. I don't know if that's
you silly man. I'm just kidding.
I mean, I'm just utilizing my resources.
Exactly.
So for 30, you're probably still loading, Jesse. I'm sorry.
I didn't really want to put in my go find my quiz. Yeah. Let's go see if I can, I guess, duplicate my results. Okay, so 14 days, what we were saying is 14 days.
So I think the test statistic is 1.316.
Ooh, that's not what I got. Uh-oh.
No, I might be looking at the wrong one. What did you get for it?
I got 1.685. Let me pull up my.
That's what I got. 1.685.
Oh yeah, my bad. Yeah, I was looking at the wrong one.
Okay.
My bad.
Okay. Oh, that's not even the first question. I didn't even. Okay, so I forgot to do the dependent samples test. Whoops.
And then what did you get for the p-value?
I got 0.096.
Yeah, that's what I got too. So then 0.0096 is less than 0.10.
Oh, it was 0.10.
Yeah.
Oh, wow.
So for this one, we're rejecting the null. So
what? I didn't even look at null. Did they give a null? Or let's see. If there's a difference in the mean cost of nonstop flights when the tickets are purchased.
Yes. So the null would be there's no difference. So we're basically saying there's
Basically, null would be 14 days equals 90-day price, and then the alternative hypothesis that they're not equal.
So I put B for the last one.
Did you say B?
Mm-hmm.
Yeah.
Yay.
All right, make sure I saved all my answers. Submit.
That we do.
Fingers crossed. Oh, I said I missed 3 of them. Oh, geez.
I just missed 1.
What did I do wrong?
Missed 15. Or is the failing to reject?
I missed number 4.
Yeah, I missed 15 as well.
Oh, wait. Yeah, I missed 4 too.
So 4 and
15. I missed 9.
I missed 10. I thought we put them all the same.
What did you guys put for, okay, let's go question by question. So I'm assuming we all got question 1, right?
Yeah.
What's the first one? So I missed question 4.
Yeah, I missed that one too.
4, which is appropriate.
Oh dear.
Deferred.
I remember this is the one you thought where it might, was this one you thought it might be the difference of means and independent samples?
Yeah, I wonder if that's it.
I think it's C.
Are you already opening another quiz, Susan?
No, I'm making notes.
Okay. Let's see. The next one I missed was number 9. What did you guys put for number 9?
For 9, I put.
I wonder if 38.
I put 38.416.
38,000, right?
Oh yeah. I guess that's a comma. Yeah, 38,416.
Oh, I mistyped. That's why I put 146 instead of 416. I love my fingers. Well, I mean, at least I was right, so that's fine with me. Not really worried. What's the next one somebody missed after 9? You said 10?
Yes, 10.
I put D for 10.
Did you get it right?
Yeah.
Yeah.
Well, I'm confused by that one. Because they're trying to say.
So you understand that the null hypothesis is that they're equal.
Uh-huh.
And so it says the tenant group thinks that the apartments are smaller than advertised. So they think that. Yeah. So they think that the mean is. Yeah.
Actually less than 1250. Yeah.
Oh, I was thinking, okay, 12. Never mind. I was completely wrong. Okay.
All right. What was the next one that someone missed? The next one I missed was 15.
15. I missed 15. Darn.
Okay, so let's look at that one. Cigarettes with certain brand is normally distributed. Mean in milligrams and known standard deviation. Brand advertises. Test the hypothesis that include that you should. So what is the calculation that we would do with that?
For which number?
For number 15. Is there some sort of calculation we could do?
I'm gonna pull it up really quick because I actually closed out of it.
Because that would that'd be like a t-test, wouldn't it? But like, I'm gonna see if I can do this.
Because like I don't think there's any calculation you could do because it's basically telling you what the sample mean is.
Yeah, but don't we want that T-score? Or does that even matter?
Well, because we don't have what the T-score was for the original one. It just gives a standard deviation and the mean.
0.5 level of a significance, 0.5. So what I was thinking, tell me if you think this is off. If the standard deviation is 0.17, and that's from 0 out or 0 out, you know what I mean, the 0.15 out, half of that, because it's a 0.5 level, which means half of a standard deviation would be half of 0.17. It's still within normal. Oh, you know what? It's not. I don't know what it is. Okay. So my numbers that I got using only half the standard deviation was 1.615 to 1.445. So it's still within there. So I'm a little confused.
Actually, I just realized this is a Z-score thing, not a T-score. But I mean, it's the same difference, really, because we know bar X, we know mu, we know sigma, and we know the sample size.
So I guess I need to do this a different way. You know, sample size. Where am I? We know sample size. We don't know you.
No, in this case, we do.
Yeah.
Well, they say that it's 1.5, I should say.
We say it's 1.5.
So
are we looking for? We're gonna look for the P-score, right? The Z-score. Maybe I'm wrong. So Rx is 1.53 minus 1.5. At the bottom, we know it is 6.7. And then the square root of 100.
It's wait, hold on. Let's see. We're trying to find out. Yeah, I think it's bigger. Barely
Bigger. Yeah, the way I figured it was.
Because I got a Z-score of 1.765.
Did you?
Yeah. Well, let me guess. Would this be... No, because they're trying to find out if it's right-tailed. No, so I still got smaller. So we would reject. Dang. So I guess I should have done some math on this one.
Yeah. So what you did, you just basically found the Z-score to see if it was less for each mean. Is that basically what you did?
15.
So for the Z-score, did you get 0.17647?
Whoa,
which is
what?
larger than, smaller than?
So I got 1.765. Are you talking about for the Z-score?
For the Z, yeah, I did the Z-score thing.
And you got what?
For the Z-score, I got 0.17647. I mean, we'll round it, of course, but
that's not what I got. Because for the Z-score, you set it up. Let's see, it's it's so bar x minus mu divided by standard deviation divided by the square root of the sample size.
Right.
So the way I set it up was 1.53 minus 1.5 divided by 0.17 divided by square root of 100.
Right. So it'd be 0.03 divided by 1.7, correct?
0.017.
Oh.
Yeah. I almost did that too. I was like, you got to move the decimal place the other.
Oh, no. 0.017.
Yeah.
And then when you times it by, or divide it by 10, right? Maybe that's where I did it wrong.
Yeah, so when you do 0.17 divided by 10, you move the decimal place to the left. So it becomes 0.017. So then the problem becomes 0.03 divided by 0.017, and you should get 1.765.
Yeah, I multiplied instead of divided in that bottom. So.
And then when you put that into the probability applet, and it's right-tailed, so you're only looking to the right because they're saying it's bigger. The probability, the P is 0.0388 or 0.039, and so we would end up with the level of significance less than 0.05, and so we would have rejected the null.
So we rejected.
Wah, wah.
Darn.
That's all good.
At least we know. Okay, so how do we do for the rest of them?
Everything else we were good. I got right, except for, like I said, I screwed up typing on that one problem.
I'm
and put 146 instead of 416.
Okay, so I missed 3.
Yeah, I missed 3 of them.
There you go. Awesome.
All right. Well, I think we did pretty good.
Yeah, I mean, we seem to know what we were doing for the majority of them.
I almost wish we could take tests in groups.
It's funny. I was actually thinking the same thing when we were taking the group quiz. Like, man, wouldn't it be nice if the actual exam was like this?
I actually had what class was that? It was one of my math classes where we took the exam, and then we took the exam with a group. And it was really interesting. I kind of enjoyed it, but it's not very common.
So did you take the same exam twice?
Mm-hmm.
And then did they just take the higher score?
No, I want to say, like, I can't remember how the scores evened out, but like, I want to say like the group one counted for a little bit less, because it was less dependent on you, kind of thing. But it still counted for points, if I remember right.
Awesome.
Anyway, I think we did pretty good. Any questions, anyone?
No, you guys were a big help to me. Thank you.
No, yeah, it's always nice being able to talk through everything with you guys.
Yes. Well then, shall we sign off and meet again? Who is going to run on Monday?